Okay, so yesterday we did a question in which every of the element was repeating twice, and there was one number which was not repeated, and we found out that number using bit manipulation techniques. We just XORed all of the array and we got the answer. So today, let's say we have an array. Um, let's say we have 4, 2, 1, 2, 3, 5. But just repeat it, 4 and 1. In this array, every of the element is repeated twice except two numbers. These numbers are 3 and 5. 4 is repeated twice, 2 is repeated twice, and 1 is repeated twice. What we are supposed to do is to find out these two numbers which are not repeated. Yesterday, it was like every of the element was repeated twice and there was just one number which was not repeated. So we took the XOR of all of the elements and we directly got the answer. Today, there are two elements that are not present, which are not repeated. So let's see how we'll approach this question. What if I take the XOR of everything? What will be the resultant value if I take XOR of everything? 3 and 5, cool. Okay, so the resultant is 3 XOR 5. Okay, so um, let's say we'll just write down the binary representation of all these. 4, 2, 1. Just a second. Yeah, 4, 2, 1. Then 3 and 5 are repeated, right? We'll just leg them off as of now. 4, 2, 1, 2, 3, 5, 4, and 1. So, in the resultant of 3 and 5, it is 0, 1, 1, 1, 0, 1, 0, 1, and 1. Now, for any of the different bit that is here, it will produce a set bit, right? Somehow, let's say I am able to divide this array into two portions, into two bags, where both of the non-repeated elements are in different arrays, 3 and 5 are in the different ones, and rest of them, whichever the repeated, can be here or can be here, doesn't matter. So this problem will boil down to this problem. Got this point? Okay. Let's say we divide this array into two parts. The part size is not defined, it can be any part. Let's say we have two bags. The non-repeated element, one element should be in one bag and other element should be in another bag. Rest all of the elements can be either side. If 4 is coming here, it will come here only. If 2 is going there, 2 should go there only. If 1 is coming here, 1 should be here only. If it is not, it should come here only. We have to divide it in such a way that the non-repeated element are in the different bags, and every of the repeated element can be in the either of the bags. So this particular solution, if you will take XOR of all these, you will get 5. If you take XOR of these all, you will get 3. Got this point now? Okay, cool. Okay, so yeah, what we were discussing, that every of the set bit here represent that there were the different bits in this particular bit position. Cool. So now 3. Okay, so we'll take this bit position. Let's say it was first position, second position, and third position. According to the second position, we will divide all this array. I'll just write down the binary representations. Um, okay, so let's say we were taking the second. We can take any of the position that is set bit. We are going for the second. We can go for third. We can go for fourth. We can go for anything. For any of the set bit, we'll take its position. Let it be the second position, right? So for every of the second position, there can be two possibilities for any number. Either it can be 0 or either it can be 1. Is that correct? So now let's go for 4. The second bit is 0. We will put it here. 2, the second bit is 1. Then sorry, 2. I'll go to 1. The second bit is 0. 1. Then 2, the second bit is 1. I'll go to 3. The second bit is 1. I'll go to 5. The second bit is 0. Then I'll go to 4, 0, 1, 0. So now when you have these two arrays or the bags, these problem boil down to yesterday's problem. You'll take just the XOR and you'll get the answer. Taking XOR of 2 to 3 will result the 3, and taking XOR of these all 4, 1, 5, 4, 1, 4 and 4 will cancel, 1 and will cancel, and the resultant will be 5. So you'll just print out these 5 and 3. This is the result. This was what we were there in the array. 3 and 5 are non-repeated. Got this point, or do you want me to repeat anything? Okay, we can, in the resultant of 3 and 5, we have to divide 3 and 5 into the different bags, right? So we are just taking the second bit into the consideration because this and this are having different bits. If we'll take this and this bit, 1 and 1 or 0 somewhere, we'll not be able to divide. So in the resultant bit, whichever is the bit set, let's say third bit or the fourth bit, which one is having the set bit, it will produce out the result. Let's go for the third bit. It can also be done. It's not just like that we are going for second only. Any of the bit that is having a set bit in the resultant, we can go for that. We'll go for the third bit now. Again, for the third bit, there will be two possibilities, 0 and 1. 4 will be here, 2 will go here, 1 will go here. Sorry. Okay, so 2 will go here, 1 will go here, 2 will again come here, 3 will again come here, 5 will go this side. We are taking third bits into the consideration. Again 4, 1 will come here. Now again in this bag, 2 and 2 will cancel out each other in XOR, 1 and 1 will cancel out each other in XOR, and we are left with 3. Again in this bag, 4 and 4 will cancel out in this here, and 5 will be there. You got this? We can go for any of the set bit in the resultant. We cannot go for the unset bit because these bits are equal. Okay, so we'll write some pseudocode for this question now. I'll write some code. This is a pseudo code, not the perfect one. So the very first thing is that we have to take the XOR of all of the elements so that we can get the bit position. That's what we did. We took the XOR of these two and we were iterating on and some bit position that is set. So for every I in array, I'll say I have a end XOR in XOR variable. XOR equals to XOR of I for every of the element. So now we have taken the XOR of all elements. XOR of all elements. The second step is to find out any of the set bit position. Let it be second, let it be third, or let it be anyone. We'll just go for the very first one because while iterating we'll get it while iterating the very first set bit we'll iterate with we will proceed with it. Okay, let's say I have a variable int position, initial value is 0. So we'll go for int I from 1 to 32. If check bit function, check bit of XOR at ith position, we'll say position equals to I and break. You got this point? Okay. So now after taking XOR of all of the elements, we are supposed to get any of the set bit. Okay. So this is the XOR variable and we have to find the position of any of the set bit. Let it be anything. We have to just find any one of the position that is set in the resultant. This is our resultant XOR. So what I'll do, the maximum number of bits it can have, this XOR variable, int XOR, that can be 32. There can be just 32 bits, right? So I will iterate on every of the bit from 1 to 32. I'll check bit that XOR value, the ith position is set or not. As soon as I get a set position, I'll break the loop and come out. Now I have a variable POS position in which there is a position of the set bit in the resultant. Now we will have to divide the array into two halves. So what we will do is to maintain two variables. Let it be num1 and num2. We'll not create two array lists as such. We'll just, as soon as we'll encounter some new element, we'll just take the XOR with the resultant. Okay. So we have int num1 that is 0 and num2 that is 0. So for int I, just a second. So for every of the I in array, what we'll do is we'll check if check bit of, let's say it's value. So for every of the value in the array, we'll check the ith bit. If it is 0, let's say this is for 0, we'll taking num1, and for 1, we are taking num2. I'll say num1 is equals to num1 XOR the value, else we'll XOR the value with num2. Simply print these two numbers. Got this portion? Okay. So let's say we are given an array in which every element is repeating thrice, and there is just one element which is not repeated at all. That is just one occurrence of it. We have to find that particular element. So let's say we are having an array of n size 2, 3, 4, 2, 4, 3, 3, 5, 4, and 2. 2 is repeating thrice. Okay. 3 is repeating thrice. 4 is repeating thrice. And the element that we are having that is non-repeated, we have to output this particular element. You're clear with the question? Okay. Okay. So let's say for the time being, I'll not consider this. I'll just write down the binary representations of all this. 2, 3, 4, 2, 3, 3, 4, and 2. For 3, it's 0, 1, 1, 0, 0, 1. Let's say we'll consider this column very first. So this is the first column, second column, and the third column. I'm saying count of first column zeros. What is the count of zeros in first column? That is 1, 2, 3, 4, 5, and 6. Count of first column ones. This is 1, 2, and 3. Count of second column zeros. 1, 2, 3. Count of second column ones. Again, the count of third column zeros, it is again 6. The count of third column 1, it is again 6. So now what the all point is, you can see these all are the multiples of 3, because in this particular element, in this particular array, every element is repeating thrice. Let's say if every element was repeating 4 times, then it would have been a multiple of 4. If the elements were repeating 5 times, it would have been the multiple of 5. Because every element is there 3 times or 4 times or 5 times, whatever the thing is, that particular bit position will come that many number of times, so it will produce a multiple of that particular number. So now when I consider 5, when I take this 5 into the consideration, let's say 5, it's 1, 0, 1. Now after considering 5, we get the C1 zeros will be equal and C11 will become 4. In this case, C2 0 will become 4, and in this case 1 is added, C3 1. This will become 7, a non-multiple of 3. This will cut out, C2 0 and C1 1. So now when we are having this particular as a multiple of 6, that means that this number in this particular bit position, this is an extra bit. If we would have considered only the repeated elements, then this was the case. Now when we are considering 5, the one bit, the position, I mean for this particular column, this particular bit is repeated, coming one extra. For this column, this particular bit is coming one extra, and for this particular column, this bit value, the set value is coming one extra. So now it's 1, 0, and 1. That is the equivalent of 5. You got that? You got this point? Okay, cool. So now what all we have to do is to count the number of zeros and 1 in a particular column, and we have to find that whether the number of zeros or ones is a multiple of 3, 3x or 3y. Whichever is not a multiple of 3 will be the value, will be the bit in the resultant number. Got this? Okay. Okay, so we'll write some pseudocode for it. Uh, you are given a function in which you are given an array. Let's say our result is initially 0. So now for int I 1 to 32. Okay, when you are writing this particular program, that's 32nd bit is the signed bit. So you'll have to stop this particular loop at 31. You'll not go to the 32nd bit because that's a signed bit representation. So on this particular, these are the columns, because for an int variable there are 32 bits. So the maximum number of columns can be 32. We were considering just 3 over here, but for any of the given array there will be 32 columns, right? So that's why we are considering 32 over here, 1 to 32. What I have to do, for every of the column I need to get a count of zeros and ones. Let's say I will have a count of just zeros or just ones, because anyhow I will get the another number by just subtracting it from the length of the array. So let's say we have a count variable that is initially 0. What I'll do is that for every value in array, for every value in array, I'll say if check bit of value of I, I'll say count plus plus. So every time it will encounter 1, it will say count plus plus. So this particular count is having the count of these, the number of set bits in that particular column. So now I'll say if count, do we need to separate count var for 0 to 1? Do we need to separate? Uh, yeah, okay, so this will come inside. Thank you, Somshekar. Because every time we have to, no, wait, it will come there only. Yes, for every of the array element, for every of the column, we have to get this count, and for every count, we have to iterate over every of the element we are having in this array. Got this point? like this count. Yes, yes, yes. We are using this count variable to count the number of set bits. Count variable in the actual program will be different, right? No, no. It will, yeah, it will be as it is. Okay, so there are some total number of array. There is some, the array size is n. If we are having 1 bit positions as x, then zeros will be n minus x. We can just directly get it, right? We don't have to count every time. Or we can, you can also have count 1 and count 0, and you can do that. But we can directly also get this from here. So now what I'll say is I have to generate this number. I have to generate this number 101. This is a result actually in the actual program. This is a bit tricky part. Please pay attention over here. This is the result. We are having it as 0 as of now, all zeros. So now I'll say if count modulus 3 is equals to 0, I mean for that particular bit position there is 1, because sorry, not equals to 0, my bad, not equals to 0. That means for that particular position there is a set bit. What I'll say is to left shift 1 by I elements and or that with the result. This is how we will generate the number. I'll explain you just. Result equals to 1 I or result. So now how is this generating our number? Let's say we were having zeros first. In this particular result, we are having a 0. Now for the first column, the number of ones is 4, that is not equals to the modulus of 3. So we will go inside. I'll say 1 left shift by I by the 1 positions. It will generate this number. And we'll do an OR operation over here. So this is our number now. Currently the result value is this after first iteration. For the second iteration, the count of 1 is 6, that is a modulus of 3, so will not go inside this particular if condition. Again, for the third variable, the count is 7, that is not equal to some modulus of 3, will go inside. I'll say result equals to 1 left shift I is over 3 here, so it's 1 0 0 0 0 0. I'll take again a OR operation. It will produce me a number 101. Now here is the resultant. You got this point, that how this number is getting generated by this formula? How do we Okay, as soon as you encounter a set bit position, you will do this operation. For any of the unset bit position, for that particular result, we are already having an unset bit over there, because we are starting with 0, right? And on the starting, every of the bit is unset. So now we have to set the bits for particular bit I'm getting generated, right? So we'll do only when it is not equal to 0. The modulus 3 is not equals to 0. For every of the set bit, we are doing this. Got this point, or do I need to repeat again? Okay. Anyhow, practice this thing once in your rough copy, or else you'll not be able to get it. You will forget it. Okay. So the question was that every of the element is repeated thrice. Let's say what will our condition be in this particular example only if every of the element was repeated 4 times rather than just the 3. How the condition would have changed for this particular example. I already told you anyhow. Check that to 0. Yeah, cool. So for when every of the element is repeating 4, we'll replace this as 4. If every element is repeating 5, we'll replace this as 5. So this is a generalized approach for the numbers repeating n times and one element is not repeated. Please note it down. We'll then proceed to the next question. Should I proceed? Let me know once you are done, then I'll proceed. What is this? Divisibility check. You're talking about this particular step? Okay. So this is how we were generating our number. This was the formula. That's what we derived over here. So for every of the set position we are getting, this will come inside only and only if there is a set position. So now, according to this, so for any of the number that was already there result, we will OR that with one left shifted by I positions, so that that particular bit position will also get set. Okay, cool. Okay, so I'll proceed further. Let's say given an array, um, we'll take a small array. It will be a big question. Um, 5. We are having these 3 elements in the array. You have to find that if there exists a subset whose sum is equals to k. Let's say k is something 8. So all of what all are the subsets for this particular array? it will be 3, -1, 5, 3 and -1, 3 and 5, -1 and 5, 3, -1 and 5, and the null subset. So for any of the subset, we have to find that this particular subset sum is equal to some given k. In this case, we are having 8. This will produce the result. So let's say okay, here I'll take one more. Let's say these are the elements 3, -1 and 5. Okay, so for 0, it is representing that we are not taking this particular number into the subset, and for 1, we are considering that we are taking this particular number into the subset. What I'm trying to say, that in this subset 3 is there, we'll write 1, -1 is not there, I'll write 0, 5 is not there, I'll write 0. Again, -1 is there, so 3 is not there, -1 is there, I'll write 0. You got this point? Should I fill the table, or do you have any confusion over here? Okay, cool. So it's 0, 0, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1, and it's 1, 1, and 0, 0. Okay, so find me the decimal equivalent of these numbers. This is 4, this is 2, this is 1, that's 6, right? Yeah, that's 6, this is 5, this is 3, this is 7, and this is 0. So when we were having 3 elements over here, let's say we are having 4 and 5 and 6, the number of subsets will increase. The number of subsets are always equals to 2 raised to n. So for now, for the 3 elements, we are having this minimum value as 0 and the maximum value as 7 in the decimal representation. What you did here in this, you're talking about this particular column. It is a decimal representation of this number. This is 4, this is 2, this is 1, this is 6, 1, 0, 1, this is 5, 0, and this is 3. Okay, cool. So now, if we are able to iterate through 0 to 7, this is the minimum value we have, this is the maximum value we have. 0, 0 to 7, all of the values are present here, right? So somehow, if we are able to iterate through 0 to 2 power n minus 1, the binary representations of these numbers. If we are able to iterate through the binary representations of all these numbers, we'll get all of our subsets generated. Got this point? Please repeat the last bit. Okay. So in this decimal representation column, we are having all of the values from 0 to 2n minus 1, that is equals to 7. From 0 to 7, we are having every of the value. So somehow, let's say I am taking up 4. In the binary representation of 4, I am taking 3 as into the consideration. I am not taking 1 minus 1 into the consideration. I am not taking 5 into the consideration. As it is for every of the value, we are having some different of the bit values, and accordingly we are generating the subsets. So if somehow I am able to iterate through this particular series of number, the binary representation of these particular series of number, I'll be able to generate all my subsets. Got this point? Okay. Okay. Manpreet, what I'm saying is that in this particular decimal representation column, we are having all of the values from 0 to 7. 7 is equivalent of 2 power n minus 1. It's 3 over here, right? N. So 0 to 2 power n minus 1. If we iterate through all of these numbers, the binary representation of these numbers, if we iterate through all of these numbers from 0 to 7, I will while iterating I'll get this particular number as well. Every number I'll get, and for every of the number I'll get the binary representation, in which one will represent that particular bit position is representing the array index, and we are taking that into the consideration in the sum. And if it is unset, we'll not take that particular number into the consideration. So by doing this, I'll be able to generate all of the subsets we are having. Got it now? Or should I take another whole example as such? Okay, you got it. Cool. Okay. So what I'll do is I'll write a pseudocode directly now because we are already done with the approach. What we have to do, that for 0 to 2 power n minus 1, I have to iterate through the binary representation. So I'll say we are having some subset sum function that is taking int array, the size of array, and the int k. So how we are iterating? We are iterating from 0 to 2 power n minus 1, that I'll write here, for int I 0 to 2 power n minus 1. Let's say the sum of this particular subset is 0 as of now. We'll iterate through and it'll get. So now what I have to do is, for any of the number I am getting, let's say we'll pick up this, right? So the number of bits we are having in this particular number is 32. This is not just 3. We are taking just 3 into the consideration for the example, but if we are generating 6 as a number, there are total 32 bits. We can generate any of the number and there will be 32 bits at max. And the 32nd bit is the sign bit. So we'll iterate through 1 to 31. Or we can directly say that if we don't have to iterate it to the total 32 times, we can iterate it through the n positions only, because anyhow I'll get the set bits only in these numbers only. Everything will be unset. So we don't need to go through all of those. For int j is equals to 0, j is less than n, j plus plus. What I'll say, that if check bit of the number I with j, if it is 1, we will take this particular number into the consideration. I'll add it in the sum. and this for loop gets end here. Now, if my sum is equals to k, I'll say count plus plus. And at last, I'll return count. So this count will give me the total number of counts of the subset and denotes the number of elements in the array. So we are having these numbers only, right? So when I am returning count, this will give me the total number of subsets, total number of subsets with some k. Do you have any confusion over here, or is it clear to everyone? Okay, what's the issue? Uh, Manpreet, what's your issue over here? Acha, sorry, I thought it's not clear. Okay. Okay, so shall we, okay, write this down and then we will proceed to the next question. Can you please repeat this once? Okay, I'll repeat. So now, what we are having, that we have to iterate through 0 to 2 power n minus 1. And for every of the element, 1 will be representing that we are including it, 0 will be representing it, we are not including it. So I'll say that I am looping from 0 to 2 power n minus 1. I'll take a temporary sum variable for n elements. We are having n elements, 3, minus 1, and 5. It can be n in the general case when you are solving the question. I'll say for j is equals to 0 to j is less than n. I'll check the bit of I at the position j. If it is 1, that means we are including this particular array element, array of I, in the sum. I'll add it in the sum. After that, I'll just check that if sum is equals to k, I'll increase the count. After the every iteration, we'll just return the count. This will represent the total number of subsets with some k. You got this? Inside for condition. It's a check bit condition. Okay, it'll come. I'll go up. I'm checking the bit for this particular number here, then here, and then here. Every time I'm encountering a set bit, I'm taking this particular number into the consideration, right? But this is what we were doing in the thing, in the dry run. That's what I'm doing. I'm checking the check bit of this particular number at the jth position. J is going from 0 to n, the number of elements we are having. If it is there, if there is 1 in the bit position, I'm taking consideration into the sum. Now if sum is equals to k, I'll just increase the count and return the count after all of the iterations. Okay, so can anyone write me the time complexity of this particular algorithm? K. K is the sum that we are looking for. That is, this k is 8. Okay. So can anyone write me the time complexity for this thing? Okay, no issues. We have not discussed the time and space complexity yet. Manpreet, you're partially correct. Wait, n raised to power n power 2 or 2 power n? Okay. So I'm repeating this particular for loop from 0 to 2 power n minus 1. How many times this loop is repeating? 2 power n times? For every of the iteration, there is a for loop that is going from 0 to n. So the total time complexity will become 2 power n, sorry, 2 power n multiplied by n. Okay. So the next question is that we are given an array again. Let's say there is some three elements array, uh, 0, 6 and 8. The indexes are 0, 1 and 2. What I have to do is to find the XOR of every possible pair I have. Let's say I'm taking the indexes of these. What we are supposed to do for all possible pairs, we have to find the XOR. And after taking the XOR, we have to sum them. So you are supposed to find the sum of the XOR of all of the possible pairs. Sorry, this will. Okay, wait. This is not the question. We'll discuss it later. First, we'll discuss for all the possible pairs. You have to sum them, and you have to find the XOR of every of the possible pair you have. Okay, the question is a bit unclear. I know that thing. Let's say we are having 0, 1 and 2 indexes. We are having three elements in the array. What will be the possible pairs? 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. These can be the all possible pairs. These are the index values for a three element array. Okay. What we are supposed to do is to find this particular expression. You have to add these numbers, all of the possible pairs. We have to find the sum of all possible pairs, and then we have to XOR them up. Can you give me a naive approach for this? Are you clear with the question first? Okay. I'll just close this. But my question is that for every of the possible pair, any of the possible pair that we have, we have to find the sum of all pairs. For every of the pair you get, you have to sum them up. And then for every of the summed pair, you have to find the XOR. Let's say we are having a three element index, three length of array. The possible, okay, I'll just write it down again. 0, 0, 0, 1, 0, 2, 0, 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. What we have to do is to sum these possible pairs, whatever we have, and then XOR them up. You have to XOR every of the pair that is possible over there. Are you all clear with this question? Others, please reply. Is there any confusion in the question itself? First, let me know that thing. Okay. Okay. So, can you try solving this question first? At least give me an n square approach. Can someone give me any of the solution for this particular problem? Okay. I's n plus plus. Okay, no issues. Okay, I'll give you the n square approach first. For every of the I from 0 to n, I'll take a j 0 to n. What I'll say is I'm having a global an answer variable over here. What I'll say is answer is equals to answer XOR of AR of I plus AR of j. Are you all clear with this approach? That for every of the possible pair, this will generate all of the possible pairs and I'll make this operation. Yeah, okay, cool. So this is an n square approach. We'll try to solve this in linear time. Let's, for the XOR property, we were having A, XOR A is equals to 0. If you remember, we studied this yesterday. Let's say this particular number is representing A, 0 plus 1. 1 plus 0 will also come up to A. The XOR will cancel out each other. Same as with 0 plus 2 and 2 plus 0. Same as with 2 plus 1 and 1 plus 2. What we all have to do is to take this diagonal into the consideration. So for I 0 to n, I'll say answer equals to answer 2 into array of I. And this will just directly generate the result. Got this point? Others, please respond. Others, please respond. Are you clear with this? Okay. Somshikhar Menon offline. We were having the possible pairs as 0 0, 0 1, 0 2, 1 0, 1 1, and 1 2, 2 0, 2 1, 2 2. What we have to do is to sum this, sum all of the possible pairs that we are having, and then XOR them up. So for the XOR, yesterday we studied a property that A XOR A is 0. Now when 0 plus 1 is XORed with 1 plus 0, this both will cancel out each other. Same as in 0 plus 2 and 2 plus 0 will cancel out each other. And 2 plus 1 and 1 plus 2 will cancel out each other. What all we have to do is to take this diagonal into the consideration for our result. What I will say for int I 0 to n, answer is equals to answer of XOR of I plus I plus I plus I, or I can directly say 2 into array of I. Got this now? Okay, cool. Okay. So let's say another question is you're given a particular array and you have to find any of the pair whose XOR value is equals to some given k. Let's say you have an array and the k given is 8. You have to find any of the pair whose XOR is equals to k. You got this point? You got the question? Okay, good. So the naive approach will be to generate all of the possible pairs we have, and for every of the possible pair, I'll take a XOR and I'll check that particular value is equals to k or not. If somehow I'm getting, I'll return true, else I'll return false at the last. How will I generate for all of the possible pairs? Int I from 0 to n, int j 0 to n. I'll say that for this particular array of I and array of j, I'll take the XOR. If k is double equals to this particular value, I'll return true. Okay? So this is an n-square approach. We'll try to do it in some linear approaches. So let's say for this particular number 1, Okay, not just one. I'll take any of the array I. If array I of array j XOR is equals to k, then I can say that array of i's will be equals to array of j XOR k. Can I say this? Can I say this portion or not? Guys, please respond. That's just a property of XOR, right? Okay. So what I'll do is to create a hash set, or I can also, yeah, I'll create a hash set of all these numbers. I'll put all these numbers into the hash set for them 1, 6, 10, 1, 6, 10, 12, 13, 21. Now I'll say for every of the value in array, what I'll do is to XOR that particular element with k and will look up into the hash set. So value XOR of k, I will look this particular value is present or not. If it is present, then there is some pair according to this property that is equal to k. The XOR of that pair is equals to k. I'll check an if condition and return true. Got this? Or is it unclear somehow?